now going to turn our attention to Lesson 3, titled Physics and the Quantum Mechanical Model. You might be wondering why we're studying a little bit of physics in AP Chemistry, but we have to start believing that the electron, which truly is more energy than it is a piece of matter, behaves more as a light wave than a particle. And thinking about the quantum mechanical model of an atom, energy coming from the stream of electrons, electrons are considered to be energy packets. And there's the tie-in with the physics model. So to preview this lesson, we need to talk about wavelengths and frequencies and how fast an electron or a wave might be moving to determine the energy level it's carrying. So this section studies the electron truly is nothing more than a property of light. And electrons travel as waves and are made of particles of light we call photons. According to the wave model, light consists of electromagnetic radiation. And this might perhaps be a review from your physical science days or 8th grade science, perhaps whatever level of science you had, the electromagnetic spectrum. We're being asked to record some of those different forms of energy found in the electromagnetic spectrum. And just to kind of see this list, the gamma rays, X-rays, ultraviolet rays, visible light rays, infrared, radar, FM, TV, shortwave, and AM. And as a chemist, the interesting part to us is that visible light spectrum. You see, the frequency of the electron happens to fall within the range of the visible light. So into your notes, you're being asked to record the electromagnetic spectrum. From the 10 to the negative 14 range up to 10 to the positive 4 range in terms of meters for the wavelength, we see what's called the electromagnetic spectrum. Notice to the far left, gamma rays, very high energy rays, 10 to the negative 14th meters is its wavelength. The X-ray, the ultraviolet ray, and a very tiny portion of the electromagnetic spectrum is the visible light waves. And you can see the Roy G. Biv, as we might be familiar with hearing about the spectrum of colors. And then again, as the wavelengths get longer and longer, infrared, radar, FM, TV, shortwave, and AM. This is produced for you in your note pack and just kind of clarifying all of the energy in this form includes any of these type of rays. So as a chemist, we've mentioned that it's the visible light spectrum with which electrons fall under. Every element emits light when it's excited by the passage of electric discharge through its gas or through its vapor. And that electromagnetic spectrum of the visible light wave happens to denote the electron transfer. Every element emits light when it is excited by the passage of electric discharge through its gas or vapor. The atom first absorbs energy, and we call that entering from its ground state into its excited state. And then as it falls back to the ground state, it emits energy. And the energy just happens to fall within the visible light spectrum and comes off as a specific frequency, a specific wavelength of a known color. So when electrons gain energy, either by putting them into a flame and letting them absorb incredible amounts of heat energy, or zapping them with electricity and having them absorb electrical energy, they move from the lowest energy level, called their ground state, into an excited state, one that is of higher energy. But of course, things in nature don't like to maintain high levels of energy. If possible, they want to release those extra packets of energy, and when they do so, they release that extra energy packet, and it's called a photon. And that photon can be seen in the visible light spectrum. We're setting up in a lab when we get back together called flame testing, or the fancy word called spectroscopy, where we're going to take different metal ions and place them into a flame and see the light that comes out. Various shades of red, some greens and blues, some yellows, some violets and peach. Every specific metallic ion, when burned in a flame, gives off a unique color. It's actually quite a nice application of the electromagnetic spectrum. passing the light emitted gives off that electromagnetic spectrum. This is a good place to stop with this lesson, and I'm going to work through the section review. So when completed with this part of your notepad, start the next video and we'll work the section review there on page 6 together.